So we're in 4.3 using the first derivative and second derivative of the graph. This will be almost an exact replay, instant replay of 4.2. So in 4.2, we were finding a thing called critical points whenever the derivative was either 0 or impossible. And we used those critical points to help us imagine numbers and figure out in different gaps between the numbers whether the first derivative was positive, in which case things were increasing, or if the first derivative was negative, where things would then be decreasing. We're still going to start these problems off today doing that exact same thing. Previously, we did that to help us find local maxes and local mins. That doesn't really factor in today. What we're going to do additionally today is do the second derivative and do almost the exact same kind of a thing. The second derivative lets us find the thing called inflection points, which if I didn't give it a new name, you wouldn't have really known the difference what it was called. Inflection points are where the second derivative is 0, or second derivative is impossible. So it's the same kind of scheme, just with a different name. Our critical points helped us spot where things switched from increasing to decreasing. The inflection points will help us decide where things switch from something called concave up to being a thing called concave down, which is new today. So if the second derivative is positive, the graph is going to be concave up, meaning it's a U shape where things are opening up. If it's a negative second derivative, then it's concave down, where we have a U shape that's opening down. And we'd again be imagining numbers like in the gaps, kind of numbers of our choosing. As we do this, then there would be 4 possible pairings. You could be increasing and up. You could be increasing and down. You could be decreasing and concave up. You could be decreasing and concave down. I wouldn't suggest you memorize the shapes that I'm about to put on the notes here. I usually tend to do these a little more just again with like hand gestures. So like this is concave up. If we split that in half, this half is a decreasing half because things are coming down. This is the increasing half of concave up. If I go concave down, I need to open up a U that's going down like this, and then split it into 2 halves. This is the increasing half because it's rising. This is the decreasing half of a concave down situation. So you're going to find yourself drawing a lot of little half U's in these graphs. So again, decrease down would be that one, because concave down is the upside down U. The decreasing half of that is the right half. That would be an increasing but down, because it's increasing, but the U is opening down. Decrease up would be this little piece. Increase up would be that little piece, because again, concave up is the normal U. The increase half is the right half. Decrease half is the left half. I would think those. I wouldn't memorize those, but if you memorize them, that's fine. That's up to you. The good news today, the problems are all about the same. Okay, if we can implement that strategy, these are going to be all about the same kind of thing. So they'll give you an original thing we're trying to graph. So we're going to need to do a derivative, and then I'll factor that in a second. I'll need to do a second derivative, and I'll factor that in a second. For this top one, if I factor this, I can pull out 4x squared and get x minus 3. For the second one, I can do a 12x and get an x minus 2. So this tells me critical points of 0 because of the x that came out, and 3 from the parentheses. This gives me inflection points of 0 because the x came out, and 2. Like what we did last time with the local extrema, we're going to put these in number line order. So 0 is the one that I found that was the smallest. It's in both lists. There's nothing really special about that. 2 is my next number. 3 is my next number. So I'm just going to put those in number line order. I'm going to move these just a smidge to give myself a little more writing space in a second. A little more room there. Then we do what we did before. Imagine some numbers. So when we look at the first derivative, I need to imagine something less than 0, like negative 10. If I plug that in here where it's getting squared, that would be a positive. That's a positive. If I put negative 10 in here and do the subtraction, that's going to be negative. So we're decreasing, nothing new about that. I don't need to really acknowledge the 2 right now, because from 0 to 3, everything's going to be the same in increase-decrease world between 0 and 3. If we were doing this a section ago, we wouldn't have even found the 2 or knew that the 2 existed. So whatever answer I get for this gap, it's going to be the same for the next gap. Because really right now, this is just one big gap between 0 and 3. It's kind of like a double answer right now we're finding. So we can imagine anything between 0 and 3. We can even use the 2. It's under my hand. 1, 2, whatever. But pick any number between 0 and 3, put it in. Subtracting gets me negative. All of that stuff is going to be positive. So we are still continuing to decrease. And that was like a double answer because we didn't care about the 2. If we get above the 3, like 27, and plug that in, everything would be positive. So finally we increase, and we've been doing that before, and that's not news. What is news is now we have another level to play with. So we need to pick a number less than 0 again to put in here. Put in any negative number you like. This part would be negative. This part would be negative. Negative times negative is positive. So this is going to be concave up. If we pick a number between 0 and 2, like 1, this would be positive, this would be negative, one of each is negative, so that's a concave down. Then we need to pick a number bigger than 2, and we're going to be done. The 3 doesn't really matter to us, so whatever we do pick bigger than 2, we're going to get a double answer for that in both of these spaces, because 3 isn't really part of this game. So pick anything bigger than 2. You could pick 3 itself, or you could pick anything bigger than 3. It doesn't matter. This would be positive, this would be positive, everything's positive. So once we're beyond the 2, we're going to be ups on those. That was new. What's not new is we can also get y coordinates by plugging into the original. Okay, so the first derivative gets you that increase-decrease thing, and you had to use your imagination. This got us the up-down choice, and there again we had to imagine numbers of our own. This is going to get us the y's, but we're not imagining numbers, we're plugging these numbers in. So 0 plugged into all of that would get you 10. 2 plugged into all of that would be a negative 6. 3 plugged into that, it's a negative 17. And that's not really new, we've done that before. What is new to us is we still need to make a graph. So what I would do is just do little sketch shapes of what we were doing over there. The decrease up little sketch looks like this. Decrease down is this. Decrease up was this. Increase up is this. And then it's graph time. Take a small step to the left where I have a little bit more space to graph. Figure this out of there. So 0, 10, I don't feel like making 10 marks, so let me go something like 5, 10, 15. So there's 0, 10. 2, negative 6. Let's go over 2, and then let me count like negative 5, negative 10, negative 15. 2, negative 6 is like there-ish. 3, negative 17 is like here-ish. And then we're going to play connect the dots, but with the shapes that we pre-decided we were going to have. I need to have like a swoopy U coming into this first shape. And I can do that, so I'll come swooping in. Then this shape needs to connect the next 2 dots, and I can connect those 2 dots with that shape. So I do. Then I need the left half of a U to connect the next 2 shapes, and I can do that. And if I couldn't do that, that means something went wrong. Then I need the right half of the U to go swooping on off. From there I go. A lot of these x to the 4th graphs remind me of like thumbs down, thumbs up kind of shapes almost. If you get next to the fourth and it looks like that, that's probably a good sign. You can also graph on the calculator, so if you remember that, just hit the Y equals button, punch this in, hit graph. If it looks weird, do zoom standard. If that's not quite enough space, go zoom out. But you should be able to obtain this picture on the calculator by graphing. If we didn't have this trick, we'd have been sitting here, your original graph experience, how you used to graph stuff was you'd make like XY tables. You'd have had to make an XY table to graph this with like maybe 20 dots. I might speculate, because to get this little zigzag, you would have needed to do probably about 5 dots in here somewhere to get the shape of that zigzag. And then to figure out what was going on in between these with this little like serpentine curve, you'd have probably needed another couple points in here, like 5-ish to get that working. You probably need about 5 to get like this going. And then you probably need to do about 5 more to figure out, yeah, that's going to go forever. You might need a couple more to figure out that was going forever. It'd be quite an extensive table making thing. And that would be dependent on you, like guessing even the right numbers to plug in, which would be rough. Sliding to the right, this one's smaller, therefore shorter, therefore easier to graph. This you actually graph using your Algebra 2 knowledge in theory. X squared stuff, this is just going to be a U. So this will be a much simpler graph. But we're going to graph this by working through the process, just to work the process out. So even though this isn't bad to graph, just go through the steps. So first step, do the derivative, 2x minus 4, factor that in a second. Second derivative is just positive 2. Can't do anything about that in a second. So here I'll factor out a 2. That tells me I have a critical point just of 2, and there are not any inflection points, because there's no way to make this 0 or anything other than 2. It's just 2. We're just stuck. That's why this got a lot shorter. So this time my list just consists of 2. In a minute, I'm going to get the y coordinate for that from the original, but I don't feel like doing that yet. What I want to do first is imagine a number under 2, like 0. Plug it into the derivative. Figure out that that would be a negative, so that's decreasing. Then pick a number bigger than 2, like 7. Plug that in. The first derivative would be positive, so that's increase. Again, first derivative gets you the increase, decrease as we have been. Second derivative gets us the up, down, but since this is a positive number, we're just positive all the time. So these are both concave up. If this had been a negative number and we were stuck, these would have both been concave down, but that didn't happen. And then I'll go grab my y coordinate from the original. And if I plug 2 into all that stuff, I'm going to get a negative 1 from that. And then for graphing, the decrease half of up is this. The increase half of up is that. 2, negative 1 would live here. And I don't really like the idea of doing a graph just off of one dot. I mean, we knew we were going to get a U shape from the word go. I would get a second point figured out just to give this some sense of scale. 0 would always be my favorite number to plug in, to just get a second point to have anything happen. If I plugged 0 into that, I'd get out 3. So 0, 3 would be there, and now I at least have some sense of scale for my U shape. This is still possible here on the left, so I'm going to go like that, and then by symmetry purposes, I can just remind you. One more time. Again, the process is the same every time. No real difference. Are we still on camera over here? So we're good. So it's an x to the 4th shape, so probably going to be a thumbs up, thumbs down kind of thing. I don't guarantee that, but probable. So first derivative, second derivative, factor them both, This I can pull out 2x squared is 2x plus 3. So critical points 0 and negative 3 halves. This I can do 12x leaves x plus 1. Inflection points 0 and negative 1. Then number line order time. So 0 is not the smallest, negative 1 was the smallest. 0 is actually the biggest. Negative 3 halves is actually the smallest, so I'll retract that. So negative 3 halves is smallest, negative 1 is middle, 0 is biggest. And then we start using our imaginations. If something smaller than negative 3 halves, I don't know, negative 100, something to easily get you clear. Squaring gets you positive for this part regardless. And if I'm putting negative 100 into this, that's definitely negative, so I am decreasing. I don't need to worry about negative 1 specifically, because that's not part of this game. I just need anything between negative 3 halves and 0. Negative 1 could actually be the number that I'm imagining. So again, putting in here, this is positive guaranteed because of the squaring. If I try negative 1-ish, something like that here, that's going to be a positive number, so I'm increasing, and that's a double. Because from negative 3 halves to 0, both of these are the same answer because negative 1 was not in play. And then pick something bigger than 0, 19. If we plug that in, everything's positive, so we're increasing. And you probably noticed today, there's a lot less alternating of these things. I told you that day was coming, and that day is apparently today, that these are not going like alternately each time. Second derivative, use our imaginations again. So something smaller than negative 1, like negative 50. These would both be negatives. Negative times negative is positive. Anything under negative 1 is therefore concave up. This number didn't really factor into that game. We're just going double answer, up, up. In between negative 1 and 0, like negative 1/2, this would be negative, this would be positive, one of each is negative, so down. And then something bigger than 0, like 1,000,000, put that in, everything's positive, so we're up. I need to get y's, so plug into the original to get some y's. 0 gets me zeros. Negative 1 would get me negative 1. Negative 3 halves, I'm not feeling that one, so I'm going to do some heapsies on that one. So the negative 3 halves is going to get me negative 1.6875. Wasn't doing that one in my then graphy shapes. The decrease half of up is the left half. The increase half of up is the right half. And then this is another increase up over there. The increase half of down is the left half of it. And then it's graph mark. 0, 0 is there. Negative 1 is there. Negative 3 halves would be negative 1.5, and then down a little more than 1.5, so something like that. And then we'll play connect the dots with the shapes that are laid out in the order they're laid out. And if I can't connect them, it means I'm messed up. So I need a swoopy left half of a U there. Then I need the right half of a U to connect the next 2 dots, which I can. Then that sort of inverts, and now we've got the right half of a U, which we can do. And then goes zooming away. And there we are with our left-handed thumbs down, I suppose. Again, grab them on the calculator. That's where we are. Syllabus is going to know the homework page and numbers and stuff. 4.3, whatever the syllabus says. That's still here. I'll be 225. We're working from 9 to 21 is the game. I think it's going to start off with some smaller ones that might just be like x squareds, and then I think it'll work its way up through x cubes and up to eventually x to the 4th. I think is the biggest thing I'll have you work on. See you later.